Hi everyone, I hope you're okay, and I hope that the videos we keep uploading are helping you out. On this video, guys, I'll be tackling the fifth question from the mid-year examination, which was written in the province of Mpumalanga in the year of 2024. The mathematics paper 2 exam, guys, had 10 questions in total, so please do expect 10 videos because each and every video will answer each question. Are you together? And please, guys, do take this seriously, since knowing how to tackle exam questions will give you an edge whenever you write your mid-year exam, your preliminary exam, and most importantly, your final examination. So please, guys, do share the video to your peers so that they may have the same edge as you. And guys, please do help us grow the channel by just subscribing. Okay. This question, guys, has an errata. That means whenever the examiner was compiling the question paper, there was a small error that was there. No? So the error, guys, was in question 5.3 over there. Rather, the entire denominator. Are you together? The denominator was supposed to say sine theta minus cos theta. It is fixed there on the errata, guys. Nah? The errata is right there on the left hand side of my screen. Are you scared? So this over there has to change as well. I just wanted to highlight this, guys, before we continue. Nah? Please note that our denominator, let's say we are given sine x minus cos x all over sine x plus cos x. Then we have minus sine x plus cos x minus sine x minus the cos of x. We have to prove that this entire thing is just equal to 2 tan 2x. That's our identity, guys. Né? So our errata was just fixing our denominator over there. So let's just remove this errata so that we will maximize our screen. Okay, now let's work. Question 5.1. We are given cos 11 degrees is equal to k. They want us to determine in terms of k without the use of a calculator. Okay. If you are supposed to find things in trigonometry without the use of a calculator, we must always use a right angle triangle, right? A right angled triangle. So this angle over there will be 11 degrees and that will be 90 degrees. Since I have 11 degrees over there, that means that other angle will simply be equal to 79 degrees. Okay, and I'm also told that the cos of 11 degrees is just k all over 1. So that means my adjacent side is k, my hypotenuse is 1. And according to Pythagoras theorem, guys, you will find, you'll find that the opposite side will simply be 1 minus k squared. Né? You'll simply say 1 squared is equal to k squared plus the hypotenuse, the opposite side. Therefore, y squared, which is the opposite, is basically equals to 1 minus k squared, and then y is the square root of 1 minus k. That's how, guys, that's how we could have found the opposite side, the side which is opposite 11 degrees. Né? And then now let's answer the questions. For us to find sine 11 is just opposite over hypotenuse. So that's just the square root of 1 minus k squared all over 1. So this is just my answer. And then sine 22 can be rewritten as sine 2 multiplied by 11 degrees, which is just 2 sine 11 degrees multiplied by cos 11 degrees, right? And then this will simply give me 2 multiplied by the square root of 1 minus k squared multiplied by k, and the answer is just 2k times the square root of 1 minus k squared. So sine 22 degrees is basically equal to that over there. Okay, then now we are given cos of 19 degrees. We don't have 19 degrees, guys, in our triangles there, but we can find the cos of 19 degrees by simply using by simply using the compound angles. Are we together? I know that cos 90 degrees, cos of 19 is the same as the cos of 30 degrees minus 11. 30 minus 11 is just equal to 19. But therefore I can simply expand my compound angle rather. I'll simply have cos 30 degrees multiplied by the cos of 11 degrees plus sine 30 degrees multiplied by the sine of 11 degrees. And then this will simply give me cos 30 is just root 3 over 2. Cos 11 is just k plus sine 30 is half, and then sine 11 is just 1 minus k squared. And then this entire thing will simply give me, if I add these fractions, I'll just have the square root of 3 multiplied by k plus 1 minus k squared. This will just be my final answer, guys. Né? Okay. And then now I'm supposed to determine cos of 11.5. This angle, guys, is a half angle of 11 degrees. Ne? 5.5 is the same as 11 over 2. That means we are dealing with a half angle. How can we deal with a half angle, guys? Let me show you the identity of a half angle. Let me prove it over there. If I have cos 2 theta, I know that this is equal to 2 cos squared theta minus 1. Are you together? Please note that theta is half of 2 theta, right? So for me to find cos theta alone, that means I must take the 1 to the other side. I'll end up having cos 2 theta plus 1 is equal to 2 cos squared theta. If I divide both sides by 2, I'll end up having cos squared theta is just equal to cos 2 theta plus 1 all over 2. And then cos theta is just the square root of, the square root of 2 theta plus 1 all over 2. So if, guys, I have cos of 5.5, are you together? Cos of 5.5 can be written as the cos of 11 over 2. Are we together? But I was given the cos of 11. So that means cos of 11 over 2 is also equal to the square root of cos of 2 times 11 over 2. That will just give me 11 degrees plus 1 all over 2. Remember that, guys, over there I have 11 because I'll simply have 2 multiplied by 11 over 2 according to this thing. Ne? If I have theta over here, that means I need to say 2 theta. My theta is 11 over 2, so 11 over 2 multiplied by 2 will just give me 11 degrees. Are you together? So I can simply find the cos of 5.5 now. Cos of 11 is just equal to k. I have 1 over there plus 2. So cos of 11 degrees is basically the square root of k plus 1 over 2. That's how, guys, we could have tackled that question over there, né? Because you have a half angle identity. Okay, now we are supposed to simplify the following without a calculator. The first step, guys, in simplifying, né? I just need to reduce my angles. Make sure that my angles are between 0 and 90. Multiplied by the sine of 2x all over sine squared 90 plus x multiplied by the cos of 65 degrees. Okay, all I have to do, guys, is to reduce these two angles which have x minus 180 or 90 plus x. Ne? Okay, x minus 180, guys. Once I have negative angles, all I have to do for me to make them positive, I just need to add 360. So I know that cos of x minus 180 degrees is equal to the cos of, or let me write at the bottom, this is equal to the cos of x minus 180 plus 360 degrees. and then I'll end up having cos 360, negative 180 plus 360 is just positive 180 degrees plus x. Now I can simply reduce this angle over there. Né? If I reduce this angle, 180 plus is in the third quadrant. In the third quadrant, cos is negative. So this will simply be negative cos x. Are we together? So this guy over here, cos of x minus 180 is the same as negative cos x. Okay. So I'll simply have, let me just build my structure at the bottom as well. Okay, I simply have sine of 25 degrees, and then over there I have negative cos of x, and then the double angle for sine is just 2 sine x cos x. And then now there at the bottom, whenever guys I'm reducing a trig ratio and I have 90 plus or 90 minus, that means I must change to a co-ratio, né? But since this this trig ratio is squared, I don't have to check whether it's positive or negative. Everything that is squared will end up being positive. So this will just be cos squared x. Are you together? There's a rule that says if guys two trig ratios are co-functions of each other, and the sum of their angles is equal to 90, therefore those numbers are equal. Né? For example, sine 30 is equal to cos of 60 degrees. You can even punch your calculator, it will confirm to you. Né? Sine and cos are co-functions of each other, and then 30 plus 60 will give us 90. That's why sine 30 is equal to cos 60. Are you together? Sine of 35 degrees will be equal to the cos of 55 degrees. You can even punch your calculator, guys. Your calculator will confirm that. Are you together? So over there, sine of 25 degrees is equal to the cos of 65 degrees. Are you together? Sine and cos are co-functions of each other, and since the sum of the angles is 90, that's why these two are equal. So I can substitute cos 65 with sine 25 degrees. Are we together? And then over here, guys, I can see that this guy will cancel with this one. And then I'll be left with negative cos x multiplied by 2 sine x cos x. I'll end up having, negative 2 sine x cos squared x. At the denominator, I'm just left with cos squared x, and then the cos squares will just cancel one another, and then I'll be left with negative 2 sine x. I now know that this entire number is just equal to negative 2 sine x. Okay, and then now I'm given the identity there. Né? Question 5.3.1, I'm supposed to prove the identity. Basically, I must prove that the left-hand side of my identity is equal to the right-hand side of my identity. Okay, let's just do that right now. Remember that, guys, the errata was provided for us to fix that mistake at the denominator. Né? So my left-hand side simply says sine x minus cos x all over sine x plus cos x minus sine x plus cos x all over sine x minus cos x. Né? I'm trying to show that this left hand side is basically equal to 2 tan theta. Are you together? The left hand side is equal to 2 tan theta. I have fractions. The first thing I need to do is to add my fractions. Are you together? Whenever, guys, I'm adding fractions, all I have to do is to just find the LCD, multiply the terms with an LCD. Quick example, if you have 1 over 2 plus or minus, okay, let's say minus 2 over 3. Are you together, guys? First thing first, our denominator and our denominators are not the same, ne? So for us to work with this, our LCD, we're just going to multiply our denominators. So our LCD will be 2 times 3. Are we together? And then for us to find the numerators, just multiply each and every term by the LCD. I have 1 over 2 multiplied by the LCD, which is 2 times 3. The 2's will just cancel one another, and then 3 times 1 will just give me 3. Minus, I have 2 over 3 multiplied by the LCD. The 3's will just cancel one another, and then 2 times 2 will simply give me a negative 4. And then my final answer will just be negative 1 all over 6. If you can punch your calculator, guys, over there, it will just get you straight to the answer. All together. Same applies, guys, with trigonometry. Our denominators are not the same, so I'm just going to multiply them together. That's sine x plus cos x multiplied by sine x minus cos x, ne? And then for me to find the numerator, I'll just take each and every term and multiply it by the LCD. Are you together? Whenever I take the first term multiplied by the LCD, the sine x plus cos x's will cancel, and then I'll be left with sine x minus cos x multiplied by sine x minus cos x. Let me just show you that in over there. I have sine x minus cos x all over sine x plus cos x, ne? I'm multiplying this by the LCD. The LCD, we have sine and cos. The other one has plus, the other one has minus. Are you together? So these two will just subtract one another, and then I'll be left with sine x plus cos x. So these two brackets will multiply one another. Are you together? I'll end up having sine x minus cos x multiplied by sine x minus cos x. Do the same thing for the second term. Take the entire term multiplied by the LCD. You'll end up having sine x plus cos x multiplied by sine x plus cos x. Are you together? And therefore we can remove our brackets over there. We'll simply have sine squared x minus 2 sine x cos x plus cos squared x, ne? Minus, inside the bracket I simply have sine squared x plus 2 sine x cos x 2 sine x cos x plus cos squared x, right? And then at my denominator I will simply have at my denominator, guys, I simply have sine x plus cos x multiplied by this is just a difference of 2 squares, man, at my denominator, ne? It's just sine squared x minus cos squared x, ne? If you multiply these out, guys, you'll simply get sine squared x minus cos squared x, ne? Okay, and then at the numerator I simply have sine squared x minus 2 sine x cos x plus cos squared x minus now let's subtract let's remove the bracket now, ne? I'll have minus sine squared x minus 2 sine x cos x minus cos squared x. This thing is all over sine squared x minus cos squared x, ne? I can see that, okay, this will subtract with that one and this will subtract with that one, ne? So I'll end up having negative 2 sine x cos x minus 2 sine x cos x. This will simply give me negative 4 sine x cos x all over. I can take out an, remember that guys, the answer says it's 2 tan 2x all over cos 2x, right? For me to make the denominator to have a cos, remember that guys, tan 2x is just sine 2x all over cos 2x, right? For me to make the denominator to look like cos 2x, I just need to take out a common factor over there. Né? If I take out negative, I'll end up having a positive cos squared x minus sine squared x. And then obviously, guys, the negatives will simply cancel one another. The negatives will cancel one another. I'll be left with 4 sine x cos x at my numerator. But 4, guys, can also be written as 2 multiplied by 2 sine x cos x. At the denominator, remember that these two cancel one another, right? At the denominator, I will be left with cos squared x minus sine squared x, and then that will just give me cos 2x. This is just 2. This entire thing over there is just equal to sine 2x all over cos 2x, right? And then this is just equal to 2 tan 2x. Now I've proven that the left hand side is equal to my right hand side. The left hand side is equal to my right hand side. Are you together? If ever, guys, with fractions, just find your LCD, multiply each and every term by your LCD, and then just keep on simplifying. You will get into your answer. So that's how, guys, we're supposed to deal with this question over there. Now 5.3.2, they want us to find the values of x for which this identity of ours will be undefined. Our identity, guys, will be undefined if and only if our denominator is equal to 0. Remember that, guys, the right hand side was just tan 2x. That means our denominator is just equal to cos 2x. Okay, let me create room for us to write. So I'll just take my denominator, which is just cos 2x, equate it to 0, and then find the general solution. Find the general solution. Okay, for our identity to be undefined, our denominator must be equal to 0, and our denominator is basically cos 2x. If cos 2x is equal to 0, the entire identity is undefined. Are you together? So all I have to do is to find my reference angle. That's cos inverse of 0. I believe this will give me 90, but let me confirm. Shift cos 0. Yeah, that's equal to 90. Are we together? That's just equal to 90. And then my duty is to express the 90 degrees where cos is positive, because numbers which are greater or equal to 0 are regarded as positive, right? So I must express the 90 degrees where cos is positive. Numbers which are greater or equal to 0 are positive. So cos is positive in the first and fourth quadrant. Are you together? So I'll simply say, therefore, in the first quadrant, 2x will just be equal to 90 degrees, which is my reference angle, plus k 360 degrees. Or in the fourth quadrant, 2x will just be equal to 360 minus 90. 360 minus 90 degrees, which is just 270. Are you together? Because in the fourth quadrant, I express my angle as 360 minus. So it will be just 270 degrees plus k 360. But I was never asked to find 2x. Ne? I'm looking for the values of x, not 2x. That means I must divide both sides by 2. That means x is just equal to 45 degrees plus k 180, where k is an element of integers, or x is just equal to 270 divided by 2 is 135 degrees plus k 180, where k is an element of integers. These general solutions, guys, will give us the x values that will make this identity of ours to be undefined. That's how, guys, we're supposed to deal with this question over there. So please do stay tuned, guys, and wait for more videos. Thank you for your time.